Hello, everybody. I hope you're doing well. Welcome back to the Introduction to Machine Learning workshop in the DSGT Udemy Bootcamp. So in the last video, we've talked about some evaluation metrics for classification and regression. And we've talked about, like, for example, in classification, that accuracy is not generally the best metric, especially if you have an imbalanced data set. So what we're going to do here is we're going to take a look at the Titanic data set again. So we're going to look at the survive column and essentially plot a pie chart, right? And this pie chart will essentially kind of tell you, right, what is the percentage of people who've survived, the percentage of people who did not survive, right? So this can help us see how balances our data set, right? Are we getting a lot of people who didn't survive versus are we getting a lot of people who did survive? It's good to understand this now, right? So we have a pie chart representation versus a bar chart representation. And we're going to fit our neural network, right, on our training set, right? And see what the confusion matrix gives us, right? Now, I know that we throw this word around all the time, but a confusion matrix is very easy to interpret, right? Here's how it goes. So on one axis here, right, you have the true label, and on this axis here, you have the predicted label. This cell here with the yellow is a scenario where you've predicted 0 when the actual label is 0. So how many times do you do that? 83 times out of the total in, the test set. Here, this is predicting, 1 when the true label is 1. So this is 29. This cell here is predicting 1 when the true label is 0, and you get the idea, right? Basically, you want more entries on the diagonal, right? Because then that means your model is actually doing really well in predicting, the correct label, right? And you want less on the off diagonals, right? So you want a good confusion matrix ideally would be higher numbers on the diagonals and lower numbers on everywhere that's not the diagonals. So basically this diagonal here is the good diagonal. This diagonals here and other places in this confusion matrix are the not so ideal places. So this is our confusion matrix, and it's just a good way to understand, okay, model predicts this label. How often does it predict correctly? Like how often do you predict correctly, essentially? So what we can do here with this confusion matrix, at least in the case of binary classification, because we're classifying survived or not survived, so 0 or 1 are the possible results, we can actually compute the accuracy. We can find the true positive, the true negative, the false positive, and the false negative. So let's go through them. So accuracies, the total number of correct over the total number of examples. So it's the true positives plus the true negatives, right? Because you truly predict positive, truly predict negative, divided by the total, right? And the total will be summing up all these entries. Precision is essentially what, for the labels that are predicted as 1, what proportion are actually labeled as 1. So it's like the true positives divided by the total number of positives, right? Predicted or not, right? So that's what precision is. And recall is saying what proportion of labels that are actually labeled as 1 are correctly predicted as 1. So you can see here that precision recall, you want to understand the wording very, very carefully, right? So precision is correctly predicted positives out of total predicted positives. Recall is correctly predicted positives out of total positives, right? So like total positives in general versus total predicted positives in precision, right? So that takes care of confusion matrix. So let's evaluate our classifiers on the Titanic dataset. So this code will go through all our models and essentially fit them, make predictions, and generate a classification report. So we can see for our decision tree, how well did we do, precision recall F1 score, and our accuracy. And you could do that for logistic neural network and SVM, right? And these are the confusion matrices we get. So we can get a better sense of what's happening with these models. How is our model doing? So one thing to think about while you look at this confusion matrix for each of these machine learning models is the following. What did we discuss today? So we discussed 5 different machine learning models, and there's definitely a lot more. And one thing to really understand in this plot is, which did the best, and, using, false positives and false negatives, what do you think, how will the story change, right? Because you have the story with accuracy, but what's the story with the false positives and the false negatives, right? What do you think is more important, false positives or false negatives, right? And that really depends on your problem. And this is a lot to think about, right? But at least through this workshop, we're able to train a machine learning model. We're able to go through evaluation metrics to see how well our model did. And in the real world, you want to tell a story with your data. And the way you tell your story really matters, right? Because these are problems that you're solving. So anyway, this wraps up our introduction to machine learning workshop. Till then, tune in for the next workshop, which is on our introduction to deep learning. Have a good rest of your day.